Welcome back to Maths with Mrs. J. In our first video on basic trigonometry, we learned how we label the sides of our right-angled triangle in relation to the angle we're talking about, and we learned about the three different trig ratios. Let me just remind you of those. The easy way that a lot of people remember them is SOHCAHTOA. So let's just write this down here. So SOHCAHTOA. Some old hens can't always hide their old age. Sine of an angle is the opposite over the hypotenuse. Cos of an angle is the adjacent over the hypotenuse. And tan of an angle is the opposite over the adjacent. Now we are going to use these rules in 4 examples, and I'll talk you through them. We'll also learn how to use our calculator to help us because the question is asking to 2 decimal places. Before you begin using your calculator, most people tend to have a calculator like that. It's gone. There we go. Something like that. Now, make sure it's in degrees. There should be a little DEG up the top of your calculator. If it says RAD, that's in radians, and that's a different thing, and that will not work for this. So you'll need to put it into degrees. Okay, let's start. The first step really in any of these questions is having a look at the diagram, checking that we do in fact have a right-angled triangle. Yep, we're all good there. And then labelling the sides that we have something on, whether it be we actually know the length or something that we're trying to find the length of. Now here's our 73 degrees. In this triangle, the side opposite your right angle, your hypotenuse, does have 12 centimetres on it. So that is going to be relevant. What else do we know with respect to this angle? What's the x? Well, the x is next to or adjacent to the angle. All right, we've got nothing whatsoever on this side here. This side is opposite the angle, but we're not even concerned with that at the moment. Not interested in it. All right, so what we need to do now is we need to think about which trig ratio involves the adjacent and the hypotenuse. Well, having a look at our rules, and we'll notice that it's the cosine rule. So we're going to write down our rule. Always, if you have a rule, whether you're finding area, whether you're doing Pythagoras' theorem, whether you're doing trigonometry, if you have a relevant rule, write the rule down as your first step. It helps if you don't mess up your writing, but that's okay. So cos of an angle is the ratio of the adjacent to the hypotenuse, the adjacent side over the hypotenuse. Now, our next step is going to be substituting in. So what is our theta? Theta is standing for our angle. So our angle is 73 degrees. What was our adjacent? Our adjacent was our x, and our hypotenuse was our 12 centimetres. So just going through that again, label the sides that you're interested in or that you're dealing with, work out which trig ratio is suitable, and write down the rule for that. Then you write down the same thing but with the substituted values that you've got. So what your angle is, where your x is, etc. Now, some people like to work out cos of 73 and write it to a certain number of decimal places at this stage. Personally, I think that's bringing in inaccuracies that are not necessary. Let's do the fiddling first and then just plug it all into our calculator and round off at the end. By fiddling, I mean we want to get this x on its own. Currently, it's being divided by a 12, isn't it? So x is going to be 12 centimetres times our cos of 73 degrees. Now, this is where we go to our calculator. Now, you should have it in degrees, and you should have it obviously turned on, and you're going to go 12 times and then your cos button, and then your angle is 73 degrees, and then press enter or equals, and it should come up with something like 3.5084, blah, 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 blah. We want 2 decimal places. So we're going to look at our 3rd decimal place, which in this case is an 8. So we're going to round up, and our answer to 2 decimal places is going to be 3.51 centimetres. What does this mean? That means is approximately equal to. You can either use that or that for approximately equal to, or you could say equals and then in brackets put to 2dp. All right, that's up to you. Okay, let's move on. Next example. Again, step 1 is we're going to label any sides that are relevant to this question. In this particular case, we couldn't care less about the hypotenuse, so we're not going to label it. All right. According to this angle, all right, x is the opposite side. And the 5 centimetres is next to it, so it's the adjacent side. The angle is always between your adjacent and your hypotenuse. What rule do we use that involves opposite and adjacent? We use our tan rule. So let's write that down. So tan of theta is opposite side on adjacent. Now we do our substitution step. So our theta in this case is 41 degrees. Our opposite is our x. Our 5 centimetres is our adjacent. So we're substituting in. Now we're going to do the same thing that we did in the previous example, because we want to get the x on its own and it's currently being divided by 5. I'm just going to go straight to this and then plug it into the calculator and round off at the very end. If you sort of keep rounding off throughout a question, you'll find it gets increasingly less accurate towards the end. What you should get when you do that is, I believe, 4.35 centimetres. Now let's just check, does that make sense? Yeah, that makes sense. If that angle's 41, that's almost like an isosceles triangle, so that's almost as big as that. Yep, that makes sense. Did this answer make sense? Yes, it's certainly a lot less than the hypotenuse, so yes, so far so good. Always a good idea to check that you're at least vaguely on the right track. All right, let's go through and do some more. A few more examples here. So again, our first step is going to be to label whatever sides are relevant in this situation. So in this case, we have our, that was meant to point to the right angle, we have our hypotenuse and we have our opposite. What rule involves opposite and hypotenuse? It is the sine ratio. Sine of theta is the opposite over the hypotenuse. So we start off labeling our sides, then we choose which rule is appropriate, then we write down the rule. Now we're going to substitute in. So our theta in this case is 52 degrees. Our opposite side is our x. Our 4 metres is our hypotenuse. And again, because we're dividing by 4 and we're undoing the divided by 4, we're going to multiply. And then we're going to plug that into our calculators. We're going to do 4 times sine 52 equals, and we come up with 3.15 metres approximately. If we got an answer that was bigger than our hypotenuse, then we'd know that we'd done something wrong, because the hypotenuse has to be the longest side of your triangle. All right, last one for this video. Again, label our relevant sides. This here is your hypotenuse. This is your adjacent. The rule that involves adjacent and hypotenuse is cos of theta, is adjacent over hypotenuse. Now what do? We sub in. So cos of 35 degrees is our x over 10 centimetres. So x is 10 centimetres times cos of 35 degrees. So x is approximately 8.19 centimetres. I'm not that quick on my calculator, I'd already worked these out. Okay, now in the next video, we're going to do ones where we're doing exactly the same process, but when we get to this step, we need to do something a little bit more tricky. So hang in there and we'll do our next video and I'll show you what to do.